Is AI bad for the environment? It is a question more people are starting to ask as artificial intelligence quietly becomes part of everyday life. We use AI to write emails, generate images, recommend videos, answer questions, and even drive cars. It all feels digital, invisible, and clean. But behind every AI interaction, there is something very real happening in the physical world. Massive data centers running nonstop, electricity being consumed at enormous scale, water being used to keep servers from overheating, hardware being replaced and discarded faster than ever. So the real question is not just whether AI is smart or useful. The real question is whether AI is quietly becoming one of the biggest environmental challenges of our time, or whether it might actually be one of the tools that helps us solve them. The truth is uncomfortable and complicated. AI is both part of the problem and part of the solution. Let us start with the part most people never see: energy. Modern AI, especially large language models and image generators, require extreme computing power. Training a single advanced model can take weeks or months, running thousands of high performance processors at once. All of that requires electricity, a lot of it, and much of the world still generates electricity using fossil fuels. Researchers estimate that training one large AI model can emit hundreds of tons of carbon dioxide. That is comparable to the lifetime emissions of dozens of cars, and that is just training. Once the model is live, it continues to consume energy every time someone uses it. Even when servers are idle, they still draw power. As AI adoption grows, this electricity demand grows with it. Data centers are being built at record speed across the globe. Some projections suggest AI-related systems could generate tens of millions of tons of carbon emissions per year by the end of the decade if nothing changes. And electricity is only part of the story. AI also consumes water. Data centers produce intense heat and most rely on water-based cooling systems. Fresh water is pumped in to cool servers, and much of it is lost through evaporation. This becomes a serious issue when data centers are built in areas already struggling with drought. Studies suggest that training advanced AI models can consume hundreds of thousands of liters of water. Even a single AI prompt can use measurable amounts of water depending on location and cooling methods. When scaled to billions of interactions, the numbers become staggering. In some regions, communities are now competing with data centers for access to water. This is no longer a hypothetical future problem. It is already happening. Then there is hardware.
AI requires specialized chips, powerful processors, and constant upgrades. As models grow larger, older hardware becomes obsolete faster. This leads to a surge in electronic waste. Discarded servers contain toxic materials like lead and mercury. If not properly recycled, they contaminate soil and water. By the end of the decade, AI-related hardware could contribute millions of additional tons of e-waste globally, and manufacturing that hardware creates emissions long before it is ever turned on. There are also less obvious impacts. AI-driven systems can increase consumption by making advertising more targeted and persuasive. They can support fossil fuel exploration by optimizing extraction. Local communities near data centers have reported increased air pollution and infrastructure strain. In one recent case, a major AI company faced legal action for operating energy systems that violated clean air regulations.
So when people ask, is AI bad for the environment? The honest answer is yes, it can be. But that is only half the story, because AI also has the potential to dramatically reduce environmental damage when used responsibly. AI can optimize energy grids, making renewable power more reliable and efficient. It can predict energy demand, reduce waste, and balance supply in real time. It can help solar and wind systems produce more power with fewer resources. AI can reduce emissions in transportation by optimizing traffic flow, reducing congestion, and lowering fuel use. In some cities, AI-managed traffic systems have already reduced emissions simply by improving timing and coordination. In agriculture, AI can reduce water usage, detect crop disease early, and minimize chemical runoff. In manufacturing, it can cut waste, improve efficiency, and lower material use. In environmental science, AI is being used to track deforestation, monitor ice loss, predict extreme weather, and protect ecosystems. Even in e-waste management, AI-powered robots are being developed to sort and recycle electronics more effectively than humans ever could. So AI is not inherently bad for the environment. It is powerful, and power amplifies intent. The real issue is how AI is built, where it is deployed, and what priorities guide its development. Right now, speed, scale, and performance often come before sustainability. That can change. Governments are beginning to discuss regulations around AI infrastructure. Researchers are working on more energy efficient models. Companies are experimenting with renewable powered data centers and better cooling technologies. Some are even willing to trade a small amount of accuracy for massive reductions in environmental impact. But progress will only happen if the environmental cost of AI is openly acknowledged instead of ignored. For businesses, this means choosing efficient models using renewable energy and extending hardware life. For developers, it means optimizing code and avoiding unnecessary scale. For individuals, it means understanding that AI is not free and invisible and supporting policies that push the industry towards sustainability. So, is AI bad for the environment? The honest answer is this: AI can harm the environment if we let it grow without limits, accountability, or responsibility. But AI can also become one of the most powerful tools we have to protect the planet if we choose to build and use it wisely. The future of AI and the future of the environment are now connected. What happens next depends less on the technology itself and more on the choices we make today